Hey, do you know how the physics of this car works?
No.
Well, now you're gonna know.
Let's first look at Newton's first law, the law of inertia. It states that an object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction unless acted upon by an unbalanced force. This means that one of two things can occur with an object with a net force of 0. It is either stationary or it is moving at a constant velocity. However, an object in motion stays in motion unless stopped. Let's take a car for example. If a car hits a wall, making it come to a stop, the driver will still be moving, causing them to go flying out of the car at the speed the car was traveling at. Now this, ladies and gentlemen, is the reason why we wear seatbelts, to keep us from being flung from the car and from even being thrown out of the car.
Newton's second law states that the net force, or F net, is equal to the mass of the object times the acceleration of the object. This equation allows us to calculate unknown variables. For example, if I want to know how much force a car can exert, I could look up the acceleration using the time it takes to reach 100 kilometers an hour, the mass of the car, and calculate the net force using that. The equation also showcases the relationship between mass, acceleration, and net force. If the same net force is applied to two objects with different masses, the lighter one will accelerate faster. So if you want a faster car, make the car as light as possible. The equation can also be rearranged to obtain different values. For example, by rearranging the equation to solve for acceleration, you can determine the acceleration of a recycling bin. When it's hit by a car.
Newton's third law. Newton's third law states that for every action force, there is a reaction force that is equal in magnitude and opposite in direction. These are called action-reaction pairs. Let's show how Newton's third law is used with cars. When the car tire rotates, it exerts a force onto the road. As Newton's third law would state, the road exerts an equal and opposite force back onto the car. This reaction force pushes the car forward. As the car drives, the wheels keep rotating, meaning that it gets a lot of force from the road to push forward. In this example, we see a car crashing into a green recycling bin. When the car impacts the green bin, it exerts a force on it, which in this case is the action force. As Newton's third law would state, the green bin exerts a force back onto the car, which is equal in magnitude but opposite in direction. This is the reaction force. Cars have been shown to have a very large negative impact on the environment. When a car burns petroleum or diesel, it releases a lot of carbon dioxide into the air, which contributes heavily to climate change by trapping the sun's heat. Recently, engineers have developed cars that do not run on fossil fuels. One example is a battery electric vehicle, which is a vehicle that uses chemical energy stored in rechargeable battery packs. They derive all power from battery packs and thus have no internal combustion engine. Engineers have also created a solar car, which depend on photovoltaic cells in solar panels to convert sunlight into electricity. These cars produce no greenhouse gases.